Hello guys, welcome to Ramta Solutions and welcome to your grade 12 functions. Today, looking at your past papers, and the question paper that we're looking at is the Eastern Cape September 2023 question paper. And of course, we're looking at the functions section of this question paper. So without any waste of time, let's get into it. Let me open the paper. I'm gonna pin it. Okay? I'm gonna pin it. I want it to up top right. So this is the paper, guys. This is the paper. It was written last year. Let me go to the functions section. All right. I'm just gonna zoom this. Buddy, come this side, please. All right. So functions start at page, at question 4, right? They start at question 4. And before I proceed, guys, if you are using a mobile device, please rotate your screen so you have best viewing. Okay. All right. So again, this is a hyperbola. Question 4 is a hyperbola. I'm going to remind you, a hyperbola has the form y equals a over denominators x plus p and then plus q. So when a is positive, it is between the first and the third quadrant. When a is negative, it is between the second and the fourth quadrant. This p, we call it horizontal shift. Okay, we call it horizontal shift because it's to do with movement of the function from the left or the right, okay? And then it also looks at what we call vertical asymptote, okay? It's also what we call vertical asymptote. So this is where your function is not, is invalid. Now to get this vertical asymptote, it basically means this denominator must be 0. So this is where you say x is equal to negative p. Okay, it's very important that you know this. X is equal to negative p. Now, you get to q. What is q? Q is what we call the vertical shift. Okay, is what we call the vertical shift. So this is to do with movement up and down of your function. It's also called horizontal asymptote. Okay, it's also called horizontal asymptote. This says it cuts the y-axis. Okay, it cuts the y-axis. So we will say, okay, this function does not exist where? At y equals q. Okay, this function does not exist at y equals q. Okay. So obviously, you know that when we talk domain of this guy, we are saying it is valid for all values of x. However, it is not valid only at one particular point at x equals p. What is that? This is at your horizontal. Is that so? Yeah, this is where, yeah, it is not valid at your vertical asymptote where x is equal to negative p. Now, we also talk about the range. We say it is valid for all y values except at the horizontal asymptote. Okay, this is all you need. We will talk about the axis of symmetry. Axis of symmetry, I can easily say, maybe let me do this. Axis of symmetry, I can say what you can do, and I'll show you different tricks. You can say this is y equals plus minus x plus p close brackets plus q. In other words, you take this. Okay, that's your axis of symmetry, but ensure that these ones, their coefficient is a plus or a minus. Okay, and this is your axis of symmetry. All right, so this is all we need regarding hyperbolas. Now let's answer the questions. Remember, guys, if you're using a mobile device, please rotate your screen. Okay, 4.1, write down the equations of the asymptote of f. As you can see, p is negative 5. So this means x is equal to 5. This shows that it has shifted to the right. And what is y? Y is equal to 3. Remember, in the notes I made, your asymptotes, vertical asymptote, x is equal to negative p. I said p is negative 5. So negative times negative 5 is positive. Hence, x is equal to positive 5. Q is positive 3. Okay? Perfect. 4.2. By the way, guys, these are important summaries I would like you to remember. Do this when you are practicing until they are installed in your mind that these functions are like this, okay? But of course, in your exam, you don't have to be doing this. All right? Perfect. Now, write down the range of f. The range of f, what we are going to say, we will say, you remember, it allows all y values. However, it does not allow the horizontal asymptote. So y is not equal to 3. That is the range. This is exactly what I said. Do you see that? This is what I said here. You just substitute the values. By the way, I'm sorry, it's supposed to be not equal to here. Okay? That is it. All right. 4.3. Determine the coordinates of x and y intercepts. Okay, I'm going to begin with x-intercept. I'm going to say intercepts because I don't know if it's going to be more than 1. But it's not going to be more than 1, so it's fine. So this will mean f of x is equal to 0, isn't it? F of x is equal to 0. That means 2 over x minus 5 and then plus 3 is equal to, so 2 plus 3 into x minus 5 is equal to 0. 2 plus 3x minus 15 is equal to 0. So 3x is equal to 12. X is equal to, oh, it's not 12, it's 13. My mistake. It's 13. So x is equal to 13 over 3. Okay? X is equal to 13 over 3. This is roughly 3 point, is it 3? No, 4.13. No, 4.33. Yeah, 4.33. Okay, this is roughly 4.33. But I'm not going to round it off, it's okay. And then let's look for y-intercept. In fact, there will be only one y-intercept. So y-intercept will be, where there's x, I put 0. So f of 0 is 2 over 0 minus 5 plus 3. You guys have calculators. Take your calculator and tell us what the answer is. 15. I see 13 over 5. I see 13 over 5. Yeah, 13 over 5, right? 13 over 5. You guys have calculators. So this will be for 2 point, let me see. What is 3 over 5? 2.6. I think 2.6. Yeah, it'll be 2.6. Okay, cool. 13 over 5 looks like 2.6. Yeah, correct. All right, 4.4. 4.4, it says sketch. Sketch on the graphs of, let me remind myself, this guy is 2.6. This one is 4.33. I think so, 4.33. Nah, this one I don't think so, I'm sure. Okay, 4.33. And this one is 2.6. Okay, so let's draw a graph clearly showing the intercepts. Let me see, it has shifted 5 units to the right. Okay, 5 units to the right, it's not really a big deal. It has shifted 5 units to the right, okay. And maybe Taro Tan Tataru Shuba. Oh, I messed it up. Yeah, I messed it up. Let me move it a bit here. Yeah. Yeah, and pedi taro ne tano tataro suba. 1, 2, 3, 4. Dink 4 versa. 1, 2, 3, negative, 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 0, 1, 2, okay, negative, negative. So you are y because you are x. Okay, so what we have x equals negative 5. Those were your asymptotes. X equals 5, not negative 5. X equals 5. It has shifted up by 3 units, so y equals 3. So a y-intercept is 2.6. So here I will say it's here. X-intercept was 4.33. 4.33, let me call it here. And then your function is like this. Remember, guys, it's not supposed to touch these lines. But this is it. Remember, this, what is this? This is 13 over 5. Right, this is 13 over 5. And this is, what is this? This is 13 over 3. 13 over 3. All right, 13 over 3. And this is all that. Okay. So even if you don't write these 1, 2, 3, 4, whatever, it's okay. What is important is to indicate these points, the shape, and the asymptotes. That is important, okay? And of course, label your x's. All right? Perfect. Now, let's see 4.5. So 4.5, it says, describe the transformation that the graph of f has to undergo to form h. Now, check this out, guys. Remember, f of x is 2 over x minus 5 plus 3. But what is h of x? H of x is negative 2 over x minus 5, minus 3. Oh, interesting, eh? Okay, I do see that this part is the same. Ever, it's negative. And my mistake here, it's supposed to be minus 5. And this part here, it's positive. I mean, it's negative, and this one was positive. Negative, negative. This was positive, positive. I know what it means. So I want to tell you this. So first, h of x is f of x shifted 2 units up. I'm going to show you step by step, okay? Shifted 2 units up and then reflected on the x-axis. Okay, and then reflected on the x-axis. Okay, do you want me to show you? Let me show you. So let me use a different color. So I'm going to say step 1. Okay, y is equal to, okay, y is, let me call it k. Let me call it k for now. Okay, let me call it k. Okay, let me call it k. So k of x is basically f of x. Remember, I'm saying shifted 2 units up. So f of x plus 2. What is this? This is 2 over x minus 5 plus 3 plus 2. This part here is your f of x. What is this? This is 2 over x minus 5, right? Plus 5. Happy? So far, this is my first point. This is where you are shifting 2 units up, right? So this is shifting 2 units up. Now let me show you the final step. The final step, I'm going to call it h of x. What is h of x? H of x, I'm going to say it is negative k of x. What was k of x? It was 2 over x minus 5 plus 5. What is this? Negative 2 over x minus 5 and then minus 5. Do you see it? This is the transformation that took place. Okay? This is the transformation that took place. All right? Perfect. Now, we are going to question 5. Okay, we are going to question 5. Let's see question 5. So question 5, this is let's see, we are given, they say the diagram below shows the graph of f of x equals, okay, this is a logarithmic function, log x base 2, sorry, log x base b, where b is a constant. And they say this passes through the point A with coordinates -9 and 9 and -2. Cool. Now show that b is half. To show that b is half, this I'm not going to break down as yet. I'm just going to quickly go into, or directly go into the question paper. Okay, so the questions, 5.1, show that b is 1/3. It's cool. So this is f of x is equal to log x base b. So we're given a point 9 and -2. Where there's x, you put 9. Where there's y or f of x, you put -2. So this is -2 equals log x base 9. Okay. Oh, my mistake. Log 9 base b. Log 9. Okay. So to antilog, we will say, you must be -b² equals 9. That is to antilog. Okay? Of course, guys, you know that this is what? This is b over 1/b² equals 9. It's the same as, this process is really unnecessary. It's the same as 1/9 equals b². Okay? 1/9 equals b². And therefore you can say b equals plus minus 1/3. But you have to be sure which one it is. Okay? You have to be sure which one it is. So with this one, it must be a positive. Okay? It will be positive. Okay? It will be positive because b is never negative. Okay? It will be positive because b is never negative. So we don't even have to worry about this. So it is, b is 1/3 because b is never negative. Okay? It is never negative. Remember, it is greater than 0 and also not equal to 1. Okay? This is it. Okay? Perfect. Now 5.2, determine the equation of f inverse, the inverse of this guy. So 5.2, I know it's easy, guys, but I will show you in this way. This is f of x, okay? This is f of x equals log x base 1/3. Okay? So to find your inverse, or rather to say whether it's x, substitute y, or y equals x. Okay? So we will say this becomes x equals log y base 1/3. And this will therefore mean that this is 1/3 all to the power x equals y. So I can conclude and say f inverse of x is 1/3 all to the power x. Okay. I know we can get this directly, guys, but I prefer to show you how things are done so we don't make mistakes. Okay? All right. Now, they say for which values of x is this guy greater than 0? For which values of x is f of x greater than 0? 5.3, they say f of x. This is f of x. Where is it greater or equal to 0? Oh, y value. Remember, y is equal to 0 at this point, but where is it equal greater than 0? Above x-axis. So where is that? Remember, this will never be equal to 0, so it must be greater than 0. Okay? But we're not going to consider a point below the x-axis because y values are negative. We only consider points above the x-axis. Okay? So this is when x is greater than 0, but less or equal to 1. Okay? But less or equal to 1. The reason I'm including this one is because, yes, the function exists at what? The reason why I didn't put an equal to here for the 0 is because the function does not exist at x equals 0. So our answer is simply x is greater than 0 but less or equal to 1, because they said f of x is greater or equal to. Okay, perfect. Now 5.4, write down the equation of the asymptote of g if g of x is f inverse plus whatever. Okay, so we will do this. 5.4, we know the answer already, but we will do this. 5.4 is g of x. I want you to see your answer. G of x is f inverse of x plus 1. What does it mean? On f inverse, what do you do? Where there's x, you put x plus 1. How does this affect the asymptote? It doesn't affect the asymptote, right? It doesn't affect the asymptote. Therefore, the equation of the asymptote is what? Y is equal to 0. Remember, y is equal to 0. Asymptote for an exponential function is because they come in the form y equals a times b to the x plus p plus q. So asymptotes will be y is equal to q. Now, when you look at this guy here, we don't have a q value. This is why we're saying it is equal to 0. Okay, this is why we are saying it is equal to 0. Happy? This is how we do it, guys. Okay, so let's see. We have another question. I believe we have another question. Question 6. Oh my, I love these ones. Question 6. Oh, vraag 6. So question 6, should I start it here? Yeah, let me start it here. It's okay. So question 6. In fact, this is not question 6. Question 6, I see we have a straight line and we have a parabola. So a parabola of the form y equals a b, oh my, ax squared plus bx plus c. Of course, when a is positive, it is smiling. When a is negative, it is frowning. Okay, now to find the c represents your y-intercept. Okay, now to find axis of symmetry, you will say x is equal to negative b over 2a. Maybe let me call this f of x. Okay, maybe let me call it f of x. Okay, so axis of symmetry will be x equals minus b over 2a. Or you can complete a square if you like. Okay, and then to find the turning point, it'll be minus b over 2a, which is axis of symmetry, minus b over 2a, and f of minus b over 2a. In other words, what I mean is the y value of the turning point is where x is equal to the axis of symmetry. Okay, is where x is equal to the axis of symmetry. So whatever value you got as your axis of symmetry, substitute it into your equation and you will get your corresponding y value. Right. Remember, guys, this y value here can be referred to a minimum or a maximum. It's a minimum if a is positive. It's a maximum if a is negative. Okay? Perfect. Now, for your straight lines, we don't have to talk much about them. You guys seem to be doing well when it comes to straight lines. Okay? Perfect. Oh, and I'm not talking much about domain and range. Domain, for a parabola, all x values are valid, so x is an element of a real number. And then let me say this, for the range, maybe let me address it. For the range, when a is positive, remember your function is smiling. Your range, you can say y is an element of real numbers, or you can say y is greater or equal to y value of the turning point. Now, when a is negative, it is frowning. Alright? So you can say y is an element of real numbers, but y is less or equal to y value of the turning point. Okay? This is how you do it. Alright. Okay. Now for straight line, maybe I should address this. For straight line, I should address this. Y equals mx plus c. Of course, this is y-intercept. This is your gradient. You can find it by saying, what is this? Oh, I should address this first. When it's positive, your gradient is like this. When it's negative, your line is like this. So the equations, you can use this one here, y2 plus y1 all over x2 minus xy. Or you can use the, what is this? What do we call this? Angle of inclination. So you can say it is equal to tan theta, which is the angle of inclination. Okay? Which is the angle of inclination. All right. So now let's answer the questions. So the diagram below shows the graphs of f of x equals x squared minus 6x plus 11 and g of x equals ax plus b. Okay. The graphs of f and g intersect at s and t. Okay. Where t is the turning point of f, please note they forgot is. Where t is the turning point of f, the angle of inclination of g is 63.44 degrees. Calculate the coordinates of t. All right. There are two ways to be doing this. You can complete a square, or you can say quickly x equals negative b over 2a, which is negative 6 over 2 open bracket 1. This is 3. Okay? And then you can say f of 3. So where does x on f of x? Where does x? You put 3. 3 squared minus 6 into 3 plus 11. I see this will give us 20 minus 18. Should it give us 2? Therefore, we can say t has coordinates 3 and 2. Okay, that is coordinates 3 and 2. Or if you like, you can complete a square. All right, if you like, you can complete a square. All right, if you like, you can complete a square. Option 2, and we just do it. Option 2, you can say f of x equals x squared minus 6x plus 11. With this one, you don't have to worry much about anything, so you just complete a square directly. Plus half of negative 6 is negative 3 square. Plus 11. So this is x minus 3 all square minus 9 plus 11. So what is this? This is x minus 3 all square plus 2. Therefore, t is, remember, turning point is negative q and negative p, negative p and q. So this will be 3 and 2. Okay? Perfect. Now, 6.2. 6.2 says determine the equation of g in the form y equals mx plus c. All right, cool. So first thing first, we need to know the gradient. Okay, the gradient here, remember, they gave g of x as ax plus b. So you can call it a. What is a? A is equal to tan 63.44 degrees. Guys, even if you had said m, it's okay. All right, even if you had said m, it's okay. But I want you to know that this a is the gradient. Okay, so this is equal to 2. Right, this is equal to 2. Let me write going down. This is equal to 2. Right, because you get 2.000 whatever. Right, so it is equal to 2. All right. Okay. So now moving on, we then say, okay, we have our gradient. So let's say now we have g of x equals 2x plus b. We have a point on that this line passes on. The given point is point T. What are the coordinates of point T? There were 3 and 2. So where there's x, you put 3, where there's y, you put 2. So 2 equals 2 into 3 plus b. So what is this? 2 equals 6 plus b. Therefore, we can say b equals negative 4. Therefore, g of x is 2x minus 4. Whether the value is right or it's not, it's something else, but it makes sense that the y-intercept is 4. So I'm happy with that. Okay? It makes sense that the y-intercept is negative 4. Do you see that? It is below the x-axis, right? So we are good to go. Okay? Perfect. Now, let's see. Now, they say, hence or otherwise, determine the coordinates of S. Ooh. So what we need, 6.3, what we need now at 6.3 is, S is a point of intersection of F and G. So what do we say? We will say f of x equals g of x. What is f of x? Where is it? It is x squared minus 6x plus 11. What is g? Positive 2x minus 4. By the way, I forgot to make a comment here. It makes sense that the gradient is positive. As you can see, when the slope or when the straight line is like this, your gradient is positive, right? So proceeding, we will then say, okay, x squared, this will become minus 8x plus 15 equals 0. So what we need x minus factors of 15 are, it's 5 and 3. All right? 5 and 3. Okay. So this means x is 5 and x is 3. This one of x is 3, we got it. Now we need this one. Remember, we're determining the coordinates of s. So now let's say g of 5. Whether you say g of 5 or f of 5, it doesn't matter. But what do I mean by that? I mean, since you got x values, you can substitute these x values into either f or g. You will get the same value. So the reason I'm substituting into g is because it's easy. I can find it easy faster. This is 10 minus 4, which is 6, I believe, which is 6. Therefore, s has coordinates 5 and 6. All right? S has coordinates 5 and 6. Happy? This is it. S has coordinates 5 and 6. Okay? Perfect. Now, yes, the question wanted coordinates of S. We good. 6.4. Ooh la la. 6.4. It says, for which values of x will f of x be less or equal to negative 6? I want to show you something, guys, okay? You see here we have something like this. This is point T, and then this is point S. So we know point S, its coordinates were 5 and 6. If you draw a line, let me use a different color. If you draw a straight line, and I'm going to come back. If you draw a straight line, we need to know what this point is, okay? We know its y value is 6. All right, we know its y value is 6, but what is its x value? To know that, we know this one here, it was 3, 2, isn't it? Guys, note, this is 3, 4, 5. So what does it mean this point will be? This point will be 2, 1. So this point will be 1 and 6. Do you guys get it? This point will be 1 and 6. Now let's answer the question, 6.4.1. The question says, for which values of x will f of x be less or equal to 6? It is equal to 6 when x is greater or equal to 1, but less or equal to 5. Do you guys get it? X value here is 1, x value here is 5. So below this point, this is where f of x is less than 6. Right? But where is it equal to 6? When x is equal to 1 and when x is equal to 5. So we are good to go. Okay? Perfect. Remember here, game changer was you finding this point. It was very important because here, this is axis of symmetry. It means it divides the graph into 2 equal halves. From this to this, it's 2 points. From this to this, it's 2 units rather. Okay, so it must be 2, 2, 2, 2. Okay, this is what we mean by axis of symmetry. You divide a graph into 2 equal halves. Okay. Now, 6.4.2. For which values of k will f of x plus k have real roots? Now, I need you guys to understand something. You see, when you look at this thing here, this function here, it has unreal roots. Okay? It has unreal roots because you can't find x-intercept. But here what they're saying is, when can we expect it to have real roots? I'm going to show you something. When we found this point to be 3 and 2. If you were to complete a square of this, equation, okay? If you were to complete a square of this equation, trust me, you're going to say, let me show you, f of x is equal to x squared minus 6x plus 11. If you complete a square, you will get it to be x minus 3 all square plus 2. Okay, plus 2. This tells you that the graph has shifted 2 units up. Alright? It has shifted 2 units up. For it to begin having a root, it needs to shift 2 units down. Now, when it shifts 2 units down, it will have a unit on the x-axis. Right? It'll have roots, not units. It will have roots which are x-intercept at whatever point here. Right? It will have x-intercepts. Right? It will have x-intercepts. Those are roots. It will have x-intercepts. Okay? Okay, so I'm saying it has to shift 2 units down. So this means, you're saying this is when x is basically what? Equal to, hold on. Not x, but k. K is a y value, okay? K is a y value. So when k is basically a negative 2. But does it end there? Also, when k goes further down. So when k goes further down. Okay. So then our answer should simply be when k is less or equal to negative 2. Okay, when k is less or equal to negative 2. Guys, I want to show you, with this one, I have to show you something. Okay, our answer is here, by the way. Our answer is here. This was just demonstration. This is our answer. So let me show you what I mean. I had said to you, f of x was into x minus 3 all square plus 2. Now, what happens when we shift it down? F of x plus k, let's say k is negative 2. What happens? F of x plus 2, what will it be? It will be x minus 3 on square plus 2 minus 2. What is this? It's 2. What is this? It will be x minus 3 all square. Do you see? This is where the roots are equal. Alright? Now let me take any value that is less than minus 2. Okay, sorry, my mistake here. Let me take any value that is minus 2. I'm going to take minus 4. Okay, I'm going to take minus 4. Or simply, minus 2 would do, I think. Minus 3 would do, the closest. Alright, minus 3. What do we get? X minus 3 all square plus 2 minus, sorry, this is where k is equal to minus 3. This is where k is equal to minus 3. Right, so what do we get? Minus 3. What do we get? We get x minus 3 all square minus 1. Do you see this? So this means your function has shifted 1 unit down. Or 1 unit down. Look at it. 1 unit down would mean 1 unit down. Do you see that? This is what? 3. So it means this turning point here is 3 and minus 1. Do you see that? As you can see, it has real roots now. Here are they. Can you see that? It has real roots. The previous was going to be like this. The previous was going to be like this. This one here was going to be like this. Do you see it? It was going to be like this. So this one is when you have f of x minus 2, right? So this one is when you say f of x minus 3. Do you see it? So this is why what we said is gonna win. Okay. So with that being said, ours ends here, and I would like to say to you guys, if you would like to get in touch with us, you can contact us. Check us out on our website, ramtasolutions.co.za. You can use these icons. You will see them at the top of our website. You can use these items to send us an email. You can click on this icon. It'll open your mailbox. You can send us an email. Of course, you are watching this video on YouTube. You can subscribe and like and share with your friends. And you can also follow us on your social media. In addition, if you'd like to get a Twitter, you can also communicate with us and we will arrange accordingly. So with that being said, guys, we hope this has made functions easier for you. Okay? We hope this has made functions easier for you. So ours ends here till we meet. Bye.